Start now. I will be giving, there's a little bit difference. I'm recording this. I got a better camera now. The last time we were recording with another camera, it didn't work. I was able to record in 5 minutes, so but this time, this camera allows me to record for 29 minutes, 50 seconds. So I will have to give a break after 29 minutes. So schedule changes. Every 29 minutes, 50 seconds, we will have a break. So, well, there were some questions about, many questions about the homework. Some of you did the homework, completed it, but I decided to go over the homework again, and let's do the homework in the classroom. That's the idea. So we will get a good overview of what we did already. Just to remember, some people asked me about they couldn't find the Alitalia timetable. So I created a joke here that how to find Alitalia timetable. It's not that difficult. It's just, you know, this is the description. If you write Alitalia timetable PDF on Google, it is the second item. And it is here, I created the link here. Yes, and Jonas was asking some questions about the how to do.
Yes.
So the idea, Jonas, is today we will have a class about how to do the homework. Okay. So what was the homework? This is the first thing. How to do the homework. We will look at the homework section. So, okay, what was it? Okay, I'm not going to do the Italian. If somebody can share the Italian network with us, I know most of the people just send me the Word file, but if somebody can share also the Excel file, I didn't look at the most recent ones, the homeworks. Did anybody make the Italian network, Italian flights? No. Terrible.
This is how they do their time sharing. Those who submit the homeworks do not appear in the class. Those who do not appear in the class. You know?
Anyway, I chose. I tend to think about Italy because Italy is sort of long. I was thinking that maybe it will have an effect, like it's narrow and long. So that was the reason. Anyway, then we asked for several things like comparing these countries, the domestic flights of these countries with the diameter, distribution, and clustering distribution. And then we talked about clustering coefficient histograms for all. And also the clustering coefficient versus number of neighbors graph using cytograph. So that was it. So let's do this. In case. So we have our let's start with the Turkish domestic flights. All right. So what we asked for was to first of all look at the diameter and degree distribution, and then the clustering coefficient. So let's take a look at that. And of course, the idea is to be able to compare and to be able to make say something about it. You know, it's not just drawing these things. It's also important to learn how you do it. But also, when you look at the results, you look at the diameter of one thing, Germany, you look at the diameter of France and Turkey, and you need to be able to say something about it. When you look at the distribution, we should be able to say something. All right, let's start with Turkish. Okay, this is Turkish. Okay, this is what we did. This is the list. The first thing that we learned about was the degree distribution, as you remember. There are two ways to do this. This is the list of all the edges, as you know, and the column C over here is the number of flights that we have per week. So this was, we went into the website and we recorded every edge and we put them over here. And the first thing that we learned about during this class was degrees. So how many, one node would have, the degree is that how many edges is coming and going out of the nodes. If it's an undirected node, then these two numbers are equal because there are no directions in this network, for example. But with this network, when it comes to the domestic flights, we thought about that most of the time. We imagine that the domestic flights network is, you know, it is directed, but when you think about it, the directions both ways. There will be directions in both ways. So you can consider. What I mean is that, for example, if there is a flight from Istanbul to Ankara, there is a flight back from Ankara to Istanbul most of the time. If there is a flight from one city to the other city, then most probably there will be a flight back. When you think about it, can you think of another example that you only have one direction for flight? Like you always have, for example, you go from city A to city B, but you cannot come back from city B to city A. Would there be such an example? It's very difficult, but if I'm traveling through, there is a case that when the flights are, for example, there are some small cities. You're going to be going to from one big city like Istanbul to two cities, and sometimes it happens. For example, in I don't know, I think it was in Diyarbakir, plane takes off from Istanbul, stops at Ankara, and then goes to Diyarbakir. Maybe only in that case there might be a situation that I have a city A, and there's a city B, and there is a city C, that I'm flying to B, and then to C, but on the way back, for example, I'm flying only from C to A, back to A, not stopping on B. I don't know. But the way that I recorded all of this is directional. So all the edges here are directional. From Adana to Ankara, it is one directional. From Adana to Ankara, there are 25 flights. When I look at Ankara to Adana, it's again 21 flights. So all of this information is directional, but since I have a equal number of flights coming back, I have like Adana to Ankara 21 flights, from Ankara to Adana again 21 flights. If I'm quite certain that all of the world, in all the world, it is going to be the same, then I can take this as unidirectional. So because it is directional, but both ways it equals a number of flights coming back and forth, so I may consider this unidirectional as well. But in this example, I don't want to bother too much about this, so I take, okay, this is my list, edge list, and I want to know about number of edges coming in and number of edges going out. So my assumption, my feeling for the being is that they are going to be equal for all of them. One way to do it, to calculate that, is within Excel. I don't need to go to Cytoscape in order to find the degrees, as you know. All I have to do is look at the number of, do a pivot table, as you might remember, and count number of times that a city appears on this column. That's going to be the source, so it's going to be number of edges going out. And this is going to be the target. So if I count it according to this, it's going to be number of edges coming in. So let's do it. What I do is that I first of all insert one row, because pivot table is more, is asking for a header row explaining what the columns are. This is the source column, this is the target column, and this is the number of flights column. So you would remember that we did this, where was it? Pivot table. This you can find it also in Excel. And we did, for example, this. So I put on the row, I want to have sources to appear, and I want to count not some, but I want to count, for example, any of them. It doesn't matter. So this is the result. This is the out degree, because this is now source. So what does it mean? So what it does is that it counts how many times Adana appears over here. It is 3 times. So if I come here and count Adana, it appears 3 times. That means that 3 times there are 3 edges going out of Adana. Okay? And this is, since it is, this is the node, it is the source, so this shows that there are 3 flights coming out of Adana. 3 different flights to 3 different cities. Okay? So there are 3 different cities going out. One of them is Ankara, the other one is Istanbul, and the third one is, well, there are 2 Istanbul airports, so 3. Okay? So I have Ankara, I have Istanbul here, Atatürk Airport 29, I have Sabiha Gökçen here 8, and Ankara is 19. Okay, so this is the result that I got. If I change this to how to change it? Let me see. All right, let me do it this one. If I do create it again, but this time if I put the target here, and again count, so I have this result. This one shows, this one was the out degree, and this is the in degree, because I'm having the target. I'm sorting this with target, counting these targets. So when I look at those two, there is a difference. You see, in here Ankara is 18, over here it is 19. So you understand what it means? So that means that I have more cities coming into Ankara than I have flights from Ankara to those cities. I have, as you see, I have 19 flights going out of Ankara, but only 18 flights are coming in. Okay, so that's kind of interesting. So this breaks my rule that I cannot consider this as a unidirectional network. I have to take it as directional network. So this was one way of doing it. I mean, what we did here is what we are doing. You remember? You want to know the degree distribution first of all. So what was the degree of the node? Degree of the node is number of edges coming in or going out of the node to other nodes. So one way of doing that is using Excel itself, because I have my data. This is how I collected it. I got the data and put it on the Excel as edge list, and then count it within the Excel. With pivot table, I can count number of edges coming in, number of edges going out, without leaving Excel. But now let's go back to cytoscape. As you remember, there is a section within cytoscape that I can easily look at the histogram, because this is not the histogram, right? This is not the histogram. This is just only the numbers. Let me do it. So cities, what is this? This is target, so this is in degree. Okay, so what I need to do is I need to sort this like this. Okay. So this is not the histogram. So in order to have the histogram, I have to count how many times that something appears. Like 20 times, there is only one city have a degree of 29. I have only one city which is 18. And I have, for example, 6 cities which have 3 in degrees. Is this the in degree? No. Yeah, that's the in degree. So, okay, so I want to know the histogram out of this. So why do I want to know the histogram? Because I want to be able to compare with numbers two networks. I have, for example, this is Turkey. I have Germany and I have France. And my prediction is that Germany, what I know is that Germany, for example, is, they don't have really, they have 2 big cities, of course. Like, what do they have? Like Munich, they have, this is a big city, or, I don't know, Düsseldorf. But it is not like in Istanbul, or this is not like in Paris, that or London, that for example, in France, Paris is way too big. In Turkey, Istanbul is way too big compared to other cities. But Germany, it is like there are several of cities that are more or less equal. So I have this feeling, but I need to be able to show it with some numbers. And to do this is by distribution. So if I can show the degree distribution, for example, with Turkey, with this, when you look at this, you see that Istanbul has, especially, for example, considering there are 2 airports, is really way too big city compared to the others. And if I can show this, I can prove it to you by showing the distribution. the degree distribution, right? So it shows me that there is this type of a network where there is one node which is more centralized. And if I look at the German network, I will see that, oh, well, there are 3, 4, or 5 nodes that are more or less similar. So how am I going to show it? I want to show it with degree distribution. So we can do it within Excel, and we are going to do it, of course, but to begin with, let's go back to Cytoscape. I'm not going to show you how to import the Excel file to the Cytoscape, because we already did that. I'm just going to, we did it before, so we'll just start the Cytoscape and just again show you how we are doing it. These are the easy bits, as you know. So this is our network. And what we want to do is we want to see the degree distribution. How to do it? It's very easy. You remember, we say analyze network. This is a directed network, as we said. And it gives us this, you will remember this. So it gives us this analysis sheet. So I have the in-degree distribution, and I have the out-degree distribution. They are more or less the same. Yeah. So I can let me save it so because we're doing the homework, you know? So when we're doing the homework, what we do is this. I finished this one. Let me go back to Germany. So, again, what I'm doing now is I want to see the degree distribution. Again, the in-degree distribution. Let me do this as well. Okay, I did it. Yes. And let me pick this one up. This is something that I'm going to show you later. But suppose that we're doing it with okay. So here is what I did. I copied the pictures. So what I want now I want to be able to compare them, so I will carry them into here so that I can compare them. Okay. because the homework was about comparing. Okay, so the one on the top is Germany, and this one is Turkey. So we are looking at the in degrees for these two countries, the flights for these two countries. It shows there is a big distinction. So my feeling is correct. My feeling was that Turkey, for Turkey, Istanbul is very centralized. It is one big city, and every flight is to Turkey. But for Germany, it is more distributed. There are not only one central city, but there are a number of cities that are, that are maybe the same importance. So that you can see this in this picture, because over here I have so many cities with only one or two or maybe three connections. You see, I have only 3 cities. You see, these are only 3 cities which are very, very central, especially Istanbul. So when you consider, of course, Istanbul, because there are 2 airports in Istanbul, if you add 8 and 28, it's going to be 36. 36. Yes, 36. 36 connections. But when you look at here, I have 2 13s, I have 1 10, I have 2 8s and 2 7s. So it is more, it gives me an idea. So that was, when you put these in words, that was the first part of the homework. And if you also put France over here, well, with France, there was let me pull it up for you. There was a surprise about France, because I was thinking it's going to be very similar to Turkey, but it didn't turn out to be like that. So I'm not really interested with the picture here. Actually, I'm interested with this distribution. For example, let me look at. So I was thinking that it's going to be very much similar to Turkey, with Paris equivalent of Istanbul, but it is not the case. I mean, yes, there is, and of course, thinking about that, there are 2 airports again for Paris, Charles de Gaulle and what was the other one? Orly, yes, Orly. So it was a little bit similar. It is not like Germany. Definitely it's not like Germany, but it is not as centralized as Turkey. With Turkey, there was a big gap, as you remember. There was Istanbul here, and all of the rest was here, and Ankara somewhere there. But in here, I can see that there are some big cities as well. So that was the difference. So you can also talk about that in the homework, that you can type these things. The things that I say is the things that you should be typing in. And if you were to look at Italy, I don't know how Italy will be, because that was the reason that I asked you to do it. If somebody did it already, newcomers, there are some newcomers in the class. Did anyone did you make the Italian flights? Yeah, or anyone? No, still nobody yet. Okay. You did it. Oh, great. You did it. Okay. How it looks like in Italy? It's like this. It's like there is one big city, right? Rome.
Yes.
And maybe Milan is also big. So you would like to see that too. I'm curious. I want to know how Italy does it. It doesn't look like Germany, I believe. If we were to do US, for example, US would be, there wouldn't be any centralization like we have in France or in Turkey, right? It will be really distributed. So this is the first part.